Hi, I'm Dr. Papia Bhattacharjee. In this problem, we are given this series. We have to figure out whether this series converges or diverges using ratio test. So, let me first remind you what ratio test is. So, to apply this test, say to any series of the form AN, you have to first compute the ratio of AN plus 1 and AN. So what does that mean? That means this term is given to you, that's the general nth term. You have to figure out the next term, the n plus 1th term, and form this ratio. Then you have to take the absolute value of this ratio and take the limit as n approaches to infinity. And then evaluate the limit. It turns out if the value that you will get in the end, if it is less than 1, that means the series converges. If it is greater than 1, that means the series diverges. And if it is equal to 1, then there is no conclusion using ratio test. You have to use a different test. Okay. Now, let's consider our series, and look, the series is of the form AN already. So this is AN. So let's write that down. AN is 9 to the n over n to the 5. Now there are quite a few important steps to this particular problem. The first one is very important, that you figure out the n plus 1th term correctly. So look at the nth term, and from there write down the n plus 1th term. Now how do we do that? Look, it's nothing but evaluating a function. Remember when you evaluated a function at a point, it's exactly the same thing. This is a function and n is the variable. Now you have to write down what will the function value be at n plus 1. So what does that really mean is wherever there is n, you just plug in n plus 1 there. So we have n in the exponent of 9. So instead of n, write n plus 1. And we have another n in the denominator to the power 5. So in place of n, write n plus 1 and the whole thing to the power 5. So that's n plus 1th term. Okay? Now, form this ratio. Very important to remember, in the ratio, the n plus 1th term is in the top and nth term is in the bottom. If you somehow switch it, this result will be switched as well. So you have to be very careful about that as well. Okay, so we have to evaluate the limit as n approaches to infinity, and this absolute value is important as well because you might have negative terms and then you have to make everything positive. Okay, so we have n plus 1th term is in the numerator. So 9 to the n plus 1 over n plus 1 to the power 5. And then in the denominator, you have this nth term. So 9 to the n over n to the 5, absolute value. Now, before you do anything, the very first thing you should do is make this into one fraction. So how do we do that? Look, you keep the numerator fraction as it is. So 9 to the n plus 1 over n plus 1 to the 5. And the denominator fraction gets flipped and gets multiplied to this one. All you have to remember is the denominator fraction will be flipped. So that means it will be n to the 5 over 9 to the n. There's one other thing you should notice. Look, this absolute value only ensures that we have to make everything positive. But look at all these terms. They're already positive. So we don't need absolute value anymore. Absolute of this entire term is itself. So we can get rid of the absolute value. And that will help in evaluating this limit. So keep that in mind as well. Okay. Always in ratio test, it usually happens that we can cancel out some terms. So if you notice, look, these two are the like terms, the 9 to the n plus 1 and 9 to the n. And we can cancel, right? There are n plus 1 many 9s in the top and n many 9s in the bottom. So when you cancel, what do you have? 1 9 in the numerator. And you can also actually apply the property of exponent to do that, right? The n plus 1 and the n, you subtract the exponent. So n plus 1 minus n is 1. So we end up getting 9 to the power 1, which is 9. And then we'll be left with n to the 5 over n plus 1 to the 5. Okay. Now this limit is on n. N is the variable. Of course, 9 is a constant. If you want, you can pull it outside the limit. So it's 9 times limit of. And now, this is a little trick that I will use. See, both the numerator and the denominator is raised to the power 5. So I'm going to combine them together into n over n plus 1, the whole thing raised to the power 5. And now, as we have done it before, this expression, ignoring the exponent, in this particular expression n over n plus 1, you can divide both numerator and denominator by the highest power of n. Remember that? So, we have 9 as it is, and inside we will divide both numerator by n and the denominator by n. Whole thing raised to the 5. Okay. So, n over n is 1 in the top. Bottom, you have n over n plus 1 over n. You can split it into two fractions. So, n over n is 1 plus 1 over n. Whole thing raised to the 5. And remember why we do that, right? Because we know as n goes to infinity, this 1 over n will approach to 0. So, we end up getting 9 times, this limit is 1 over 1 plus 0 to the power 5. But 1 over 1 is 1, to the power 5 is 1. So, the answer is 9. Now, look at the ratio test. Don't forget what we're doing, right? We figured out this limit of absolute value of n plus 1, that term over nth term. And what do we get? 9. And 9 is greater than 1. What does that mean? That means if the limit is greater than 1, series diverges. So, using ratio test, we can conclude that this series will diverge. So, before I finish, let me make one quick comment, and this is very important. Now, look at the series itself. Look, if you look at this expression, if you ignore the 9 to the n and just look at the denominator, see it is 1 over n to the 5, which is a p series, right? So, if the 9 to the n weren't there, this would be a p series. Now, on the other hand, if you ignore the denominator and just consider 9 to the n, that's a geometric series. So, it's like a combination of a geometric and a p series, which really means that it's neither geometric nor p, okay? Which means that you cannot apply either of those tests to this series to figure out converges or not. So, please keep that in mind. This type of series, this type of expression, when it looks like it's almost geometric or almost p, but it's neither, a ratio test is a very nice test to apply to it to figure out convergence or not. And we did figure out for this particular one that this series will diverge. So that concludes the problem. Thank you.